Thank you. There's a story behind the footwear. I stepped out of the house and we had 15 centimeters of snow, and it was 6 o'clock in the morning. I had to get to North Bay, so I thought I'd better at least change my footwear. Hello. Thank you for this opportunity. I think it's pretty exciting to see so many people coming out and learning information about biomass and energy in our future, because things are going to be changing pretty quickly in the near future, and we're going to have to make some very wise decisions, and it certainly helps to have a lot of information. So I'm with a group called Green Temiskaming Development Cooperative. We set up in the Temiskaming area after a series of meetings. We met with the public in our area. We had about 7 meetings, and people talked to us about concerns they had in the community. And there was the ones that you'd youth migration and unemployment. But the one that began to stick out quite seriously with people is energy costs. There were people saying that in the wintertime, when it got in the 2 cold months, they ran out of money for food, and they were at the food bank, and the food bank was running out. And we started thinking about this, thinking that, geez, like the energy prices aren't high compared to what they're going to be, and what are these communities going to do when they have 20 to 30% of their population just can't heat their homes? So we thought we'd take on that challenge, and what we did is we started looking around to see what other communities were doing, and we kind of fell over what was going on in Europe, and we'll talk a fair bit about that. So what we decided is, if energy prices are a problem for some people now, and that they'll be rising in the future, it's only good management to look for more cost-effective, environmentally safer methods. So local energy sources will, and energy sources that'll stimulate the economy. So we can get to go the right way. The right one? That way? Okay. All right. So district energy systems is what we're going to be talking about, and they've been used continually since the 14th century in Europe, and now there are thousands of them supplying safe, cost-effective heating for millions of people in Europe. This presentation will show that Northern Ontario has long-term secure energy source, biomass, and that the technology exists and the economics are favorable if we develop them wisely. So to do this, we want to look at why community is the optimal model for biomass energy development, how biomass energy systems work, and how to build a renewable energy sector in Northern Ontario. That was the wrong one. Okay. All right, won't hit that button again. So community energy model, the optimal model. So imagine benefits of a community creating its own energy. Think of how much money now leaves our communities to buy imported electrical and petroleum energy. So imagine these benefits of having community energy that would use local raw resources, equipment that would pay for itself, local people to bring the waste from the forest, local people to operate and maintain the equipment, and you begin to understand the benefits of community energy. So community energy is smart energy because it produces energy where it's needed. Community energy eliminates much of the energy transportation from moving and also the dumping of heat. The efficiency of community energy allows it to be delivered at much lower costs. This makes businesses more profitable, reduces the cost of home and school heating, and creates new business opportunities. So building a community model. So we had a series of public meetings. We concluded that the government wasn't going to solve our problems and that we needed to take responsibility for them ourselves. So we decided to follow the very successful European community model of development. And this led us to form the Green Temiskaming Cooperative. And it's a not-for-profit development cooperative. And the difference between it and many other development organizations is that its objective is actually to undertake the tasks of development. And we're going to be using something called the energy independent strategy. So it's a target to basically release ourselves from paying the $35 million we're now paying in our region for heat energy. So to initiate this energy independent strategy that would include in the end over 16 separate energy systems, we proposed an initial demonstration project. We call it the Biomass Demonstration Project. So to really own this district energy technology and prove the financial model, we needed a full-scale demonstration model. We needed a full town heating system that could be operated, maintained, and fueled by local trained people. This would give us and other communities the confidence we need to proceed with energy development. It would also give local financial institutes the knowledge of risk and payback they need to participate in the financial future energy systems. And this is one of our targets is instead of having these projects invested by outside investors, is that we actually use local financial organizations. And we actually have 3 people here today that are listening and becoming more educated on the aspects of biomass so that we can fund future projects. And this is with the Northern Credit Union and Caisse Populaire. They have interest in funding these projects in the long term, we hope. So the biomass demonstration project will supply heat and electrical energy for all the homes, businesses and institutions for a town of 1,200 people in Ontario. And I think this is a model that differentiates itself somewhat from the approach that northeastern US is taking. And I think I like the European model because what it does is it actually includes everybody in the cost saving. And so what we're sort of suggesting is a different style of rollout for this technology in Ontario, so that rather than starting with a series of small projects, we start off with a small town and roll it out into bigger communities. And this way we could probably have an accelerated development, something that would happen much more quickly and I think much more cost effectively than the isolated model where you do a hospital or you do a town center or you do something else. So it's basically nothing more than taking the European model that's been very successful and saying, we can do that. They'll help us and we can do that sort of development. So the information learned will allow the plant to be easily replicated and increased in size. So it'll be designed as a teaching and touring facility that will be used to encourage and support other communities. So let's take a look at the demonstration project, which is right there. The plant will use 8,000 tons of wood annually. It'll produce $2.2 million worth of energy. These plants can heat all the businesses, schools, hospitals, and homes in the small town. So the plant has a targeted payback of between 3 and 5 years, after which there will be a targeted reduction in heating costs of up to 75%. This will reduce the cost of home ownership, make businesses more profitable. Excess revenues will be reinvested in the community for further developments. So here's how it works. Most people will probably be familiar with this, but we'll just go through it quickly. So chipped, air-dried wood is fed into a high-efficiency boiler at the power plant. The steam produced in the boiler spins a turbine to produce electricity, which is fed onto the grid. In community power, the heat after the turbine is used to heat institutions and businesses through a buried insulated piping network. The heat is transferred to plenums in homes and heat exchangers to radiators to move the heat into the house. This type of system can reduce the cost significantly and reduce our overall carbon footprint by up to 40%. The new Green Energy Act will provide additional funding through the sale of electricity. And here is an example of an operating system. So in Brennick district in Austria, high in the Italian Alps, they have a population of 20,000. They have 9 separate communities. They developed a community-owned cooperative that installed, operates, and services 9 separate plants. And I think they very, very much captured one of the fundamental problems there is that small towns and communities can't afford the technical capacity to run these small plants and maintain them. It gets expensive. But if you have a regional development, which we've heard a little bit about, you can have a common set of technology, a common set of financial plan, you can have a common organization and extend the development of it quite significantly. So the plants generate electricity, heat homes and institutions in over 6,000 homes in the region. So after a 3-year payback, the Brennock region is now saving itself $43 million Canadian a year on costs and reducing their carbon footprint by over 80,000 tons per year. Heating costs were reduced around 75%. This is an economic impact on the regional economy of over $100 million annually. In 10 years since the plant was installed, the price of energy has not been raised. Since the installation, Brennock has been on the top 10 list of highest standards of living in Europe. There were thousands of district heating systems in Northern Europe, many running for over 30 years. So I brought this thing up about 75%, and when we first brought it up, we thought it was a bit out of range, but I think we've got some rationale that supports it. So why does Europe have thousands of district heating systems? It's really just smart management. A smart energy system produces energy where it is needed. Electrical utility generation is centralized. Community energy is local. Let's compare. One utility is proposing to burn pelletized wood waste in their existing boilers. This is a big improvement over coal, but I think we can do better, way better. In utility production of electricity, more than 82.2% of the energy is wasted, resulting in the delivery of less than 18%. To deliver 100 watts from utility electrical producer, it takes 567 watts of energy and machine capacity. Shipping wood pellets long distances, burning them in a plant that wastes over 82% of the energy, and then shipping the remaining waste, the remaining 17.8% of the energy back to where it is needed, is not a smart energy system. We can do better. So in a smart community energy, local air-dried chipwood is used. There is no pelletizing. Or long-distance transportation of raw fuels. In community energy, the heat after the turbine that is normally emitted to the atmosphere in large utility plants is used to heat the community. So the turbine losses effectively drop to near zero. Energy is produced where it is needed so that there is no long-distance shipping of energy. Losses from shipping energy drop by more than 50%. Energy output jumps from 17.8% to 83%, an increase in delivered energy of 466%. A community operating model would look something like this. Out of the 100 units of energy put in, over 83 can be delivered to the customer. This compares with less than 18%. To deliver 100 watts of energy, only 120 watts of energy are required. Smart energy systems are good producers of wealth. Let's look at an example. Efficient energy systems produce energy at lower costs. The owners of the energy system, in this case the community, benefits financially from high efficiency. This chart shows a price comparison. The puck on the left is the cost associated with the price of a barrel of oil in 1995. The next one on the right is the comparable cost of heating with biomass energy. The third pile, representing oil in 2007, to the right of that is the Brennock price for energy, which is a little over 7%. Not only is community energy cost effective, but community energy is independent from global energy costs. The community controls the cost of energy. This means energy costs are stable and predictable, and investors in the community know what to expect and can depend on the energy supply cost structure. What would happen if we applied this community biomass energy model across the north? In Northern Ontario, we now spend $850 million annually on imported energy for space heating alone. If we were to supply this energy ourselves, it would require 14 million cubic meters of wood annually. This would create, without any multiplier, over $2 billion annually in economic impact. This is an economic equivalent of over 20,000 permanent jobs. It would also reduce our energy costs by up to 75%, create around 2,000 permanent operational jobs, and make critical space heating energy independent of global energy prices indefinitely. Northern Ontario can sustainably produce 32 million cubic meters of wood annually. And I guess with the discussions this morning, that's a pretty variable number. But so currently 24 million are allotted to forest companies, leaving only 8 million left over for energy. Northern Ontario needs an additional 6 million cubic meters allocated for energy just to meet our basic energy needs. There's no big excess of biomass in the province that we can afford to give away at commodity prices. We need this energy to stabilize our economy. Let's look at the impact of a specific community, say North Bay. So North Bay would require 350,000 tons of waste per year to supply heat and some electricity for the city of 50,000. This energy system would produce $53 million worth of heat energy and $35 million worth of electrical energy for an annual income of $92.4 million with some addition for carbon credits. The $200 million plant and distribution system would be paid off in 3.13 years. Excess revenue after payback and a reduction in heating costs would be around $26 million a year for future investments. So a North Bay plant might look something like this. The direct economic impacts would be $122 million annually to the city. This would be the equivalent of 2,440 new full-time jobs. This assessment excludes any economic multiplier and the impact of construction. The addition of $122 million in a local economy would create hundreds of new businesses and thousands of new service sector jobs. In addition to this, the community would get permanent protection from future energy price increases. So community energy. Why does community-owned district energy work so well? Because it reverses our current economic equation. Instead of selling at low commodity prices and buying everything at retail, we can, through our community corporation, buy raw energy at commodity prices and sell it to ourselves, displacing retail-priced imported energy. This is the ultimate in value-added products. Community energy shares the benefits through the lower energy costs to homeowners on fixed incomes, businesses, and institutions. District energy promotes local investment, energy independence, long-term stability and security, and permanent long-term jobs. District energy is the ultimate in infrastructure investment because it pays for itself and reduces the cost of energy. The raw resource exists, the economics are great, and the technology is well proven over decades. We need action now. This means project development so that we can take advantage of the unique set of opportunities that now exist before us. We need people with vision and confidence to step forward and take responsibility for the future stability of their communities. Thank you very much for your time.